The show that reveals how extraordinary items in our world are designed, constructed and produced. See the engineering, the technology and big ideas that make the world go round. Find out how it works. Coming up, construction on a very grand scale. How the biggest wind turbine in the world was built. Two-piece wonder, the creation and construction of a bikini. And how the world's largest pasta company processes over 1 million tons of wheat every year. Mamma mia. But first, many people believe that when their computer no longer works, the only thing it's good for is a paperweight to clutter up their desks. But they couldn't be more wrong. These men work for a new breed of recycler who has discovered gold in old hard drives. Hidden within your old computer is a treasure trove of precious metals. The circuit board contains silver and copper, and the microprocessor is laced with gold. All of which are good conductors that carried electrical signals around your computer. The old computers are sent to a plant which salvages their precious metals. First, the outer casings are taken off. Cables are unplugged and disposed of. And then all that remains are the chips and processors. All these components were worth a fortune when they were brand new, but now they would be worth nothing if they were on a rubbish pile. This company will make a handsome profit though. 1 ton of old computers could fetch them £6,500. These microprocessors are the easiest to recycle, as the only metal contained in them is gold. A mix of hydrochloric acid and nitric acid is used to separate the gold from the ceramics. Hundreds at a time are dissolved in a large barrel. What remains is pure gold dust. This is melted into gold bullion, the stuff of dreams for any business. Other parts of a computer's interior are a lot harder to recycle since they contain a mix of metals, but the effort is still well worthwhile. The metal parts are stripped down and put into a furnace. They melt into a liquid mix of gold, silver and copper, which is poured out, cooled, pressed, and then sliced into plates. Each plate is placed into a bath and given a positive charge. Here we see it on the left. On the right, a negative charged copper plate attracts the copper particles, which loosen from the mixed metal plate and accumulate there. In the next bath, a steel plate attracts the silver, which forms in crystals. After the second bath, the plate contains nothing but gold and can be melted down. It will be shaped into different forms that have a variety of uses. These sheets can be used to make gold salt, which will be sold to the computer industry. To create the salt crystals from the sheets, they have to use cyanide, which is highly poisonous, so the engineer makes sure the container is sealed very tightly. This salt may not be so good for fish and chips, but it is excellent for computer chips. This bucket of gold salt has a value of almost £47,000. Here, the gold sheets are pinched into small plates that will become dental crowns. What once carried information around a computer's memory will shortly find a home in someone's mouth. This worker is taking made-to-measure gold rods from the furnace. They're compressed and twisted into a coil, which is then transformed into fine wire used in computer circuitry. Another industry that has a huge demand for gold is the space industry. Satellites and vehicles such as the Space Shuttle use gold in their engines. Everyone knows gold is a precious metal, but who would have thought that it would have so many industrial uses? All of these combine to make recycling old computers a very lucrative business. After they were first introduced in the 1940s, they were so controversial they were banned in Spain, Portugal and Italy. But today, bikinis are an everyday sight on beaches all over the world. Here's how they're made. First, a designer sketches out her idea. Then it's modeled on a computer. Before they make a prototype, they have to test some fabrics to check their color fast. The bikinis are going to be exposed to strong sunlight, so they blast the fabrics with UV rays to see if they're up to the job. Then they give them a good soaking to see how they react to water. But they're going to have to cope with chemicals too. They submerge the samples in chlorine to see if they can handle a few lengths in the pool. And then in a salty solution to replicate a dip in the sea. They're left in for an hour at a tropical 27.5 degrees Celsius. Once the tests are complete, they compare the samples to see how they've performed. Inevitably, some have fared better than others. Maybe the most important thing to test is the fastener. To keep a lady's modesty intact, it needs to withstand 14 kilos of pressure before snapping open. Once they've selected the fabric and checked the fastener, they can make a prototype. It may look fairly fantastic to an untrained eye, but the designers are perfectionists and make a few alterations to improve the shape. Don't bother sending in your CVs. This is a job for experienced tailors only. The pattern is plotted onto a computer and then they print out a template. On each sheet there are 30 bikinis in 5 different sizes. Before they cut the fabric, they check it for flaws. This woman marks all the nicks and tears on the roll so that they can be cut out later on. But if there are more than 15 flaws, they'll send the roll back to the producer. The template is put on top of 15 layers of the fabric, and then a vacuum sucks it into position. A computer-guided cutter carves out 450 bikinis in one go. Bikini is given its characteristic shape in another department. The two molds are heated and the fabric is stretched over them. When the cups cool, they'll be able to take a spin in the washing machine and tumble dryer without losing their shape. In the sewing hall, 120 workers stitch together the pieces of fabric. Once the top is done, they add some padding. This gives the bikini a flattering shape and makes it more comfortable to wear. To help make sure everything stays where it's supposed to, they put in an underwire. A fastener is attached with a few stitches, and the top is complete. It's hooked onto a hanger with the bikini bottoms, and it's ready to head off to a swimwear department. All it needs now is a gorgeous body, and it'll be wowing beachgoers from Costa Rica to the Costa Brava. Still to come, mass production the Italian way. How water and wheat combine to make 120 kinds of pasta. And wind turbines. The harnessing of natural power. Governments across the world are trying to cut carbon emissions, and renewable energy sources such as wind turbines are thought to be a key part of the solution. But how do they construct these massive structures? One of the first steps is to prepare the foundations. Here they're using reinforced concrete. This is the steel framework that the concrete will be poured into. The concrete can bear the weight of the tower on its own, but it has to be reinforced because, like any tall structure, it's going to face some stiff winds. Without the steel reinforcement, the concrete would deteriorate and eventually give way. The steel frame gives the concrete enough flexibility to take the battering. The foundation also has 40-meter stakes driven through it, fixing it to the ground. When the 1,200 cubic meters of concrete is added, the base weighs over 1,000 tons. All of the sections for the tower are produced by a specialist factory in Denmark. This is the bottom section. At a massive 6 meters in diameter, it's wide enough to bear the weight of the rest of the structure. The crane driver can't drop such an enormous section on a sixpence. It has to be dragged into place with ropes and brute force. Three more sections are fitted over the next 3 days. The fifth and final section is a real challenge. It's being fitted onto a tower that is already 120 meters tall. The nacelle is a powerhouse that sits on top of the tower, and this is where the wind energy will be converted into electricity. To attach it, the workers have to climb up by ladder. It's a 40-minute vertical trek, so it's definitely not a job for anyone that's out of shape or scared of heights. Now that the workers are at the top, the nacelle can be lifted up to them. This is the very heart of the wind turbine. The blades turn a rotor which is connected to a generator. This turns the kinetic energy into electrical energy which can then be stored. It passes through a transformer which bumps it up from 1000 to 20,000 volts. Then it can be diverted out to a local substation and onto the main grid. The rotor blades will be attached here. They're made in this factory. Every year they make about 1,800, but these will be the biggest ones the world has ever seen, each an incredible 61.5 meters long. The blades are made in halves that will be joined together later on. A plastic is reinforced with layers of fiberglass, and these are sewn together by hand. It's a painstaking process, but using these lightweight materials makes the blades very efficient. To finish each half of the blade, they cover the mold with a plastic shell and suck out the air to make a vacuum. Then they pump liquid resin in. Because of the vacuum, the resin spreads quickly and evenly. Over the next few days, the resin merges with the fiberglass and dries to make a very solid structure. Workers then join the halves together to make a single hollow blade. To simulate the effects of strong winds over a 20-year period, they load a test blade with a weight of over 50 tons. Then they shunt it from side to side an incredible 5 million times. It passes the test, and now 3 identical blades can be taken to the site. To move a 61.5 meter blade, you need a very long vehicle. Imagine trying to do a 3-point turn in this truck. When the 3 blades are put together, you can really see the awesome scale of this project. They work around the clock to lift the blades into place. These men inside the tower are there to guide the rotor into place. It's a scary job. They're working with enormous objects at great heights in the middle of the night. As it's slotted onto the guide bolts, the hard work is over. Finally, the wind turbine is ready to start producing electricity. This single structure will provide enough to supply 5,000 homes. We all know pasta perfection can't be found in a tin of Alphabetti spaghetti. For the real McCoy, you've got to go to Italy. This pasta factory in Parma is the largest in the world. 1,200 tons of durum wheat is delivered here every day. It's sucked out of these trucks by a giant vacuum. Wheat from other trucks is unloaded in giant sacks. They don't just need any old type of wheat. To get the right texture, they need durum wheat, which is higher in protein than other wheats. water is added to the wheat and mixers turn it into dough. They're controlled by computers that churn out perfect pasta dough every time. The dough's squeezed through grids which determine the pasta shape. The round holes make spaghetti. 1.5 meters is squeezed through, and then it's stretched to 3 meters. Any loose ends are lopped off and head back to the mixer. Once it's stretched and trimmed, the spaghetti needs to be dried so that it holds its shape. That happens in these whopping ovens. They're 200 meters long. The spaghetti will gradually dry at a balmy 70 to 90 degrees Celsius. But they don't just make spaghetti in this factory. This giant pasta sheet is being turned into tagliatelle. It gets dropped into these bowls and then heads off to an oven. A spinning blade cuts the pasta tubes at an angle to make penne. Then the penne is funneled along a vibrating chute towards silos where it'll dry out. The vigorous shaking helps to keep the pasta moving and stops it from sticking together. When it's dried, it tumbles out of the silos and is ready to be packed. The size and number of these giant silos helps give you some idea of just how much pasta is produced here. The spaghetti's dried out too, but it's still got to be cut to size, 26 centimeters to be exact. It's divided up into 500-gram portions, which are then slotted into packets. The scale of production is truly staggering. Every year, this company makes 120 varieties of pasta, with a total weight of over 1 million tons.